Alright, so we've done point slope form, and now we're going to go to slope intercept form, which may actually appear to you initially, and actually I guess more long term, possibly as the more simple version, but you'll see why we did point slope form first in just a second. So we're starting with point slope form here just to give you kind of the connection here. So remember, y minus y1 equals m times x minus x1. Talking about graphing this line, you remember from point slope form, you could graph it by figuring out x1, the point, would be negative 2 comma 3, negative 2 comma 3 from this equation, and then the slope would be negative 2, which we could be negative 2 over 1 or 2 over negative 1, but would tell you go down 2 and right 1, down 2 and right 1, down 2, right 1, or up 2 and left 1. So I'm putting many points, but one important principle when you're doing graphs is, generally speaking, you want your graph to fill up the page, and my line's not perfect. We'll be using some rulers to kind of help and make sure our lines are looking fairly straight, whereas I can't really use a ruler on this program. But point and a slope. What I want to show you is now how we can actually write this and how you're going to see slope-intercept form, and I know some of you have possibly been tempted to do this already. But slope-intercept form, to do this, we would just we're going to simplify and do some things that we've done plenty of times this year, which would be distributing. Y minus 3 equals, and so times negative 2, that would be negative 2x, and times negative 2, that would be minus 4. And then slope-intercept form actually has y all alone on one side of the equation. So y equals negative 2x, and the negative 4 plus 3 is negative 1. What you should, so this is slope-intercept form. What we want to know is, and we kind of look for is, where do we see these numbers, negative 2 and negative 1, on our graph? Well, hopefully you can identify negative 2 as the m value up here. So negative 2 is actually, if you remember, this is called slope-intercept form. Negative 2 is still our slope value. So this is the exact same line. Both of these equations, this equation and this equation, describe the same line. Negative 2 is still the slope number. But where does this number 1 come in? Well, remember, this is called slope-intercept form. If we look at the name, where is this intercept? Well, notice, here's negative 1, 0, negative 1, and we went through that point specifically. This is your y-intercept. So when we look at slope-intercept form, the general format, and what you need to make sure you have down, and we'll say this a million times and it'll just be stuck in your brain. Remember, the y and the x are there, so you can have the option of plugging in numbers. There's your input where you put numbers in. There's your output where you get numbers out. You get a value for y. Y equals mx plus b is general standard slope-intercept form, how we write out slope-intercept form. The m still stands for slope, but now the b value stands for your y-intercept value. So if you remember, when we've identified the y-intercept, sometimes I've said to you, some people have asked, like, okay, the y-intercept is negative 1. Do I have to list it out as 0, negative 1? Well, no, you can just say the y-intercept value itself is negative 1. So slope-intercept form is just a different way of writing the equation of a line. Y equals mx plus b. So I'm going to do a slope-intercept form for you. Write the equation for a line with a slope of negative 3 and a y-intercept 0, 5. So again, this is my m value. We're doing y equals mx plus b. That's our general slope-intercept form. And then the y-intercept is our b value. So the equation would read y equals -3 goes in for the slope, and 5 goes in for the b value. If you're writing an equation, we always have to have this x and this y part, so we have somewhere to plug in and get our different values that go in our table. So slope-intercept form. Here's one for you to try. Write the equation of a line with slope of 7 that goes through the point 0, -1. So if you pause and try it, again, y equals mx plus b, 7 is your m, -1 is your b, so we could say y equals 7x plus your b value, or more likely we'd want to write it as y equals 7x minus 1. So either one is correct, but generally speaking, we don't write plus negative very often. We would just write minus. So slope-intercept form in and of itself is pretty straightforward when you're given the slope and the y-intercept. Notice it's the y-intercept. This is not the same process if it was the x-intercept. So the other skill that you're going to be, or another skill you're going to be expected to do, besides just having, when I give you the slope and the y-intercept, writing the equation, is, okay, now how do we do this when we actually have 2 points? And this is where it comes in. Why did we do point slope form first? Point slope form, we want to think of point slope form as kind of our gateway to writing slope-intercept form. So when you want to write an equation, and it should say here, we're assuming that we want to do this in slope-intercept form. When we're writing an equation in slope-intercept form, if you think back to that first problem I did, it was pretty straightforward as far as changing from point slope into slope-intercept. So what I'm going to do, and I'm going to show you 2 different ways to do this problem. Well, actually, I'm going to show you 2 different ways, but both ways start with the exact same process. And you think slope-intercept or point slope, what common thread do I have that I need? Well, I need to find the slope. The slope would be the change in the y values, so the change in the y values, 4 to 3, would be -1. The change in the x values, -3 to -1, would be up by 2. So the slope is -1/2. Either method, you're going to start with the slope. But where we go from there is where it may kind of diverge and go into 2 different directions. You should end up with the same answer though. If I go to my step 2, and I'm going to make this is going to be the method that uses point slope. The method that uses point slope would say, now write your equation in point slope form. So for point slope form, I'm going to choose the point, I'm just going to choose -3, 4 because that was the first one I came to. In point slope form, the equation would read y minus 4 equals -1/2 x, and then minus -3 would be +3. To change this into now, I want to write my equation in slope-intercept form. If you write it in point slope form first, now all you have to think is, how do I get y all alone? So to get y all alone, I'd want to distribute y minus 4 equals -1/2 x. -1/2 times 3 is -3/2 or -1.5. Now how do I get y alone? I would add 4 to both sides. So the equation, although it looks a little odd because we have some decimals and fractions, would be -1/2 x, and -1.5 plus 4 would be plus 2.5. So this tells me, looking at this equation, the slope is -1/2, and now it's like I have a third point that I know about. I know that the y-intercept is 0, 2.5. That is the method using point slope form. The second method, though, involves a little bit more of a solving turn. And the way I'm doing this is it's kind of just going straight for slope-intercept form. So if you think about kind of reset yourself from number 1 here. If I'm writing my slope-intercept form, y equals mx plus b. What do I actually know out of this equation? Well, I know the slope is -1/2. Well, that's really all I can fill in. I don't know, short of doing the problem fully out. I don't know what the y-intercept is yet. But do I know an x and y? Well, x and y just represent a coordinate pair. So if I choose the point, say, -1, 3. -1 represents an x value. 3 represents a y value. If I plug those in, 3 equals -1/2 times -1 plus b. Now I've left myself the option where I can solve for b. 3 equals -1/2 times -1 is 1/2. Now how do I get b alone? I would subtract 1/2 from both sides. So I get 2.5 equals to b, and now I know what the slope is from my original step, and I know what the y-intercept is from my second step. I can now write the equation y equals -1/2 x plus the y-intercept value, which was b. So you notice I got to the same equation. Both processes can lead me there, but it's just two different methods. Do you have to use both? No. Do you have to feel comfortable with both? No. Personally, the point slope method is going to be much more straightforward and much more just using the knowledge that you already have, which is easier to build off of. So here's one for you to try. Pause it and try it. This is the end of the video, but answer-wise, if I find my slope